The moon, our closest celestial neighbor, has captivated humanity for millennia. It hangs in the night sky, a beacon of light and wonder. A source of myths and legends, the moon also holds the key to understanding the history of our solar system. Its presence has shaped our culture, influenced our tides, and inspired countless dreams of reaching for the stars. For centuries, astronomers have studied the moon, mapping its surface and deciphering its secrets. We've sent probes and even humans to walk upon its dusty terrain. With each mission, we've learned more about this celestial body, yet it continues to hold mysteries that beckon us to explore further. The Moon is Earth's only natural satellite, a sphere of rock orbiting our planet at an average distance of 238,855 miles, or 384,400 kilometers. This distance is roughly 30 times the diameter of Earth, making the Moon a relatively close neighbor in the vast expanse of space. Its diameter is a relatively small 2,159 miles, or 3,474 kilometers, just over a quarter the size of Earth. Despite its smaller size, the Moon's presence has a significant impact on our planet. Despite its size, the Moon plays a crucial role in our planet's stability. It helps to stabilize Earth's axial tilt, which in turn regulates our climate and seasons, making life as we know it possible. The Moon's gravity is about 1/6 that of Earth's, meaning you'd weigh significantly less standing on its surface. For example, a person who weighs 180 pounds on Earth would weigh only 30 pounds on the Moon. Temperatures on the Moon are extreme, ranging from a scorching 253 degrees Fahrenheit or 123 degrees Celsius in the sunlight to a frigid minus 387 degrees Fahrenheit or minus 233 degrees Celsius in the shade. These drastic temperature changes occur because the Moon lacks an atmosphere to moderate the heat. The Moon has a very thin atmosphere, almost non-existent, called an exosphere. This exosphere is composed of sparse particles including helium, neon and hydrogen, but it is far too thin to support life as we know it. This lack of atmosphere contributes to the extreme temperatures and makes liquid water impossible on the lunar surface. Without an atmosphere, there is no protection from the sun's radiation and no way to retain heat during the long lunar night. The leading theory for the Moon's formation is the giant impact hypothesis. This theory proposes that early in the solar system's history, a Mars-sized object named Theia collided with the young Earth. The impact was cataclysmic, ejecting a massive amount of debris into space. Over time, this debris coalesced under its own gravity, eventually forming the Moon we know today. This violent birth explains several of the Moon's characteristics, such as its composition being similar to Earth's mantle and its relatively small iron core. The impact also likely tilted Earth's axis, giving us our seasons, and set the stage for the development of life as we know it. Section 4. A tapestry of lunar features. The Moon's surface is a desolate yet captivating landscape, scarred by billions of years of impacts from asteroids and comets. Craters of all sizes pockmark the terrain, evidence of a tumultuous past filled with violent collisions. Some of these craters are enormous, stretching hundreds of miles across, creating vast depressions on the surface. Among the craters lie vast plains called Maria, Latin for seas, which are expansive and smooth. These darker regions are not actual seas, but rather ancient lava flows that solidified billions of years ago, creating a stark contrast to the surrounding terrain. Towering above the Maria are lunar mountains, some reaching heights comparable to Earth's tallest peaks, standing as silent sentinels. The lunar highlands, lighter in color than the Maria, are heavily cratered and represent the oldest surfaces on the Moon, offering a glimpse into its ancient history. Section 5. The Moon's dance with the Sun. As the Moon orbits Earth, we observe its phases, a cycle that has fascinated humankind for millennia. This celestial dance has been a source of wonder and inspiration, influencing cultures, calendars, and even tides. The phases are caused by the changing angles at which we see the sunlit portion of the Moon. As the moon travels around Earth, the sunlight it reflects changes, creating the familiar phases we see each month. A new moon occurs when the moon is positioned between Earth and the sun, rendering it invisible to us. This marks the beginning of the lunar cycle, a moment of renewal and new beginnings. As the moon continues its orbit, a sliver of reflected sunlight becomes visible, marking the waxing crescent phase. This phase symbolizes growth and the gradual increase of light. The illuminated portion grows until we see a half-lit moon known as the first quarter. This phase is a balance between light and dark, a perfect equilibrium in the lunar cycle. The waxing gibbous phase follows with more and more of the moon illuminated until we reach the full moon. This phase is a time of anticipation as the moon nears its fullest expression. During a full moon, the entire face of the moon is bathed in sunlight, creating a brilliant orb in the night sky. This phase has been celebrated in myths and legends, symbolizing completeness and illumination.